Okay, this is problem 2 of homework 3. It might be problems 2 and 3 depending on how long it takes. In problem 2 it says consider MLT3 encoding used by Ethernet physical layer. It asks you to use graph paper or spreadsheet to draw the MLT3 waveform for each case described below. And they give you parts A and B with 2 sets of binary data. In part A, it says the signal level on the first bit is a -1, and on part B it says the signal level on the first bit is a +1. So let's look at the solution here. In MLT3 encoding, if you recall, we're going to get a transition on a 1-bit, and we're going to we're going to transition the voltage when we get a 1-bit, and we're going to keep the voltage steady on a 0-bit. And every time we transition, we're going to cycle through the pattern -1, 0, +1, -1, or -1, 0, +1, 0, -1, 0, +1. So basically cycling up and down. Okay, something like that. And so what I've done here is I've got graph paper and I wrote the bit pattern up here, 1 per square, and I've got a 0 line here, and I can go 1 square up or 1 square down from that. And on part A, the first bit was a -1, and that means that the next bit I get is going to be transitioning to a 0. Or the next transition I get goes to a 0. And the bit I get is a 1, and that means I do a transition. Now notice that that means we can tell, we can actually tell backwards in time a little bit that this first 1 had to have caused the transition from a 0. Okay, so we can kind of tell that there was a 0 at time t equals -1. But that's not our concern. The 1 means we made the transition. The 1 means we transitioned to 0. Another 1 means we transition up to 1. And then I get 2 zeros, so I stay up at a +1. And then I get a 1 going down to 0 voltage. And then 4 zeros staying at 0 voltage. A 1 takes me down to -1 volt. And a 0 causes me to stay, and then 4 1s cause me to transition through 0, +1, 0, and -1. Okay. Similarly, on part B, here I write my bit pattern in the graph paper. I give myself a 0 line, and as it says, the signal level on the first bit is a +1. So you can similarly tell back in time, you know that at time t equals -1, it had to be a +1 because a 0 bit would have kept it the same. In any case, we have a 0 bit at a +1. A 1 bit causes us to transition to a 0. I stay at 0 until I transition 3 more times to -1, 0, and +1, staying at 0, cycling through and following the pattern. So there's what those 2 patterns look like.